So here we are. The next problem is the problem of definite integral. It's going to be a trickier one for us. The limits are 0 to 2 pi, and inside this greatest integer you can see the expression is little bit complicated. It is sin 2x whole into 1 plus cos 3x. Now how to deal with it? If you know a very important property, that is the property of definite integral, if we have f(x) from 0 to a function which is to be integrated, you know, if you replace x with a minus x, the value of the definite integral is not going to be changed here. So this is a very important property which we will be using here. Now let's say this integral is I equal to 0 to 2 pi. Now again writing the entire expression here, sin 2x whole into 1 plus cos 3x greatest integer. Now if I replace x with 2 pi minus x using the same property, you can notice what will happen here. If I replace here x with 2 pi minus x, again x with 2 pi minus x, again here, let us see what is going to happen. You can notice here that this will become, now there is a greatest integer as well, you know it. Now this will become 4 pi minus 2x. Now the fourth quadrant is there, so this will give you a negative sign, that is minus of sin 2x. Now again here this will be 6 pi minus 3x. So this is again in the fourth quadrant, but you know it is going to be positive. So it is 1 plus cos 3x. Now notice this, again what we have got here is the additional negative sign we have got here. The integral is definitely from 0 to 2 pi. Now what to be done here? This is integral I and this is also integral I. Now you can notice again a very important property, that the greatest integer of x plus the greatest integer of minus x is equal to minus 1. This will happen for any value of x which is not an integer. At integral values, this plus this will be equal to 0. Now you can again notice this entire expression will become integer at very few values of x. Now they are ignored. Why? Because we are taking a certain interval. The point is ignored because that area is not countable, that will not make any change. So if we add this I and this I, definitely the sum will be equal to minus 1, and we can easily do this problem here. If I am adding this I and this I, that is 2I will be equal to 0 to 2 pi, the sum is definitely minus 1, and if you integrate this and find the value, this is equal to minus 2 pi, and hence I is equal to minus pi. So you can see a very difficult problem can be dealt easily by using this important property of definite integral. Now again let us see another question. The next question is related to the concept of determinants. There are two determinants which are given here, and there are two variables as well. One is x and another is theta. The second determinant is again almost same. You can see here the options are related to the value of the determinant, the sum of determinant and the difference of determinant. Now you can notice there is no connection between the various variables. So applying any of the property of determinant is of no use. So straight away the terms not being so complicated, we will straight away expand this determinant, that is the first and second determinant here, we are going to expand it. So, simply expanding the first determinant, you will see the value will be equal to minus x cube, and again if you expand the second determinant, that too will be independent of theta, and that will again give you value minus x cube. So, simply by expanding both the determinants, you can notice the value will be independent of theta, and definitely the sum of delta 1 and delta 2 is equal to minus 2x cube. So, the option which is correct is the first one. Now, let us move on to the next problem. The next question is related to the concept of continuity. It says that the fx is a continuous at x equal to 0, and fx is given in this way. For less than 0, it is defined differently, involving a constant p which is not known, and again at x equal to 0 it is q, and for x greater than 0 it is an irrational function. Now, we know the concept when a function is continuous at a particular point. The point is x equal to 0. We know that the function is continuous if the left hand limit at that particular point, the right hand limit at that particular point is equal to the value of the function. So, for the left hand limit at x equal to 0, we will be using the first one, and for x greater than 0, that is right hand limit, we will be involving this function. So, we are here to calculate the limit, that is the left hand limit first, then we will calculate the right, and the value is equal to q. So, here we are first for the left hand limit. Limit x tending to 0 minus, we have sine of p plus 1 into x plus sine x upon x and definitely upon x. Now, here you can see when x is tending to 0, this is 0, this is again 0, multiplying numerator and denominator with p plus 1, this limit will be equal to p plus 1, and this is definitely equal to 1. So, the value is p plus 2. Now, again for right hand limit, we have to calculate the next part, that is this function we will be dealing here. So, from here we have right hand limit x tending to 0 plus, we have a root of x plus x square minus root of x upon x raised to the power 3 by 2. Now, you can notice root of x is common in the numerator and denominator. So, we are going to cancel this out. So, from here we have cancelling root, x is tending to 0 plus, we have 1 plus x minus 1 upon x. Now, if I rationalize this, multiplying the numerator and denominator with under root of 1 plus x plus 1, we have this will become, that is the numerator is 1 plus x minus 1, which will be cancelled with this x. Now, we are left only with this term, that is under root of 1 plus x plus 1. Now, putting x equal to 1 here, this will give you value, actually 0 here, this will give you value 1 upon 2. So, this is the right hand limit. So, what we do here, we are going to equate, that is the left hand limit which was equal to p plus 2, the value of the function which is given, that is q, and the right hand limit, that is equal to 1 by 2. So, from here P is equal to minus 3 by 2 and Q is equal to 1 by 2. So, the option which is correct here, that is equal to minus 3 by 2 and 1 by 2, that is the second option is the correct one. Now, let us move on to the next problem.